Hello everyone. Welcome you all for the post-contest discussion of Leetcode Weekly 413. So let's start with the discussion. This is the first question for the day. The question name is check if two chessboard squares have the same color. So you are given two strings, coordinate 1 and coordinate 2, representing the coordinates of a square on an 8x8 chessboard, and below is the chessboard for reference. So like you can see, the coordinates are like you have A, B, C, D, E, F, G, H. This indicates the columns and these indicates the rows 8, 7, 6, 5, 4, 3, 2, 1. Okay. So you need to return true if these two squares have the same color and false otherwise. Okay. So if you are given two coordinates, so two coordinates will refer to two squares. So if those two squares have same color, you need to return true. Otherwise, you have to return false. Like for reference, if you look up this first example, the coordinate 1 is A1 and coordinate 2 is C3. So if you just go to A1, how we will go to A1? Eighth column and first row, A1. So you can see A1 is black and C3. So C3. So you can see C3 is also black. Now, since A1 and C3 are of same color, you returned true. Similarly, you can check that A1 and H3 are of different color. A1 is black, whereas H3 is a white. H3 is a white. So since they are not of same color, we are returning false. So this is the question. So how we can do this? So just understand one thing over here, that if let's suppose you were not given A, B, C, D, you were given a normal coordinate. Okay. You were not given A, B, C, D, something like that. You were given like, let's suppose this is a chessboard. Let me see if I can copy that. So if this is a chessboard, so if I let's suppose tell you that, okay, this is not A, B, C, D, this is let's suppose numbers. These are let's suppose 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now just figure out that, okay, for a particular cell, when is the cell black? So the observation was that if you observe nicely, you will observe that, okay, for this particular cell, the row is 1 and column is 1. So when you add these rows and column values, you will get an even value. Similarly, for this particular cell, the row is 1, the row is 3, and the column is 1. If you add, you will get an even value. Similarly, for this, you will get even value. Similarly, if you observe for the white cells, then the value of row for this particular cell is 2, the value of column is 1, and this turns out to be an odd number. Similarly, if you look for this particular white cell, then the value of row is 1 and the value of column is 2. This turns out to be an odd number. Okay, this will be odd, this will be odd, 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 odd. So what we observed was that the value of row plus column, if it is equals to odd, this means that the color is white, else the color is black. Now, when we were able to add these two rows and columns, when we don't have this A, B, C, D, instead of having this A, B, C, D, we have the numbers 1, 2, 3, 4. Now, how we can convert this alphabetical characters to numbers? It's very easy, right? If you are given character A and you want to get that what particular number of this character A is, like as we know that the English alphabets are A, B, C, D, E, F, G, S, something like this. And if we say that A is 1, then B will be 2, C will be 3, D will be 4, E will be 5, F will be 6, G will be 7, and H will be 8. So instead of these characters, I want this number. How we can do that? So from this character A, you are given character A, right? You are given a string. Let's suppose you are given a coordinate A1. So from this, you can extract this character A by going to the first character of the string. Now from this character A, simply subtract character A. So what you will get? You will get 0 and simply add 1 to it. So you will get that according to character A, you will get number as 1. Try to do the same thing for B as well. You have character B. You subtracted character A from it. What you will get? What will be the result? The result will be 1. When you add 1 to it, you will get 2. So according to character B, you will get 2. So how you can convert any character to these numbers? So given a character, just subtract character A from it. And if you add 1, so this will give the corresponding number of that character. And once you have this, the job is done. Because now you know that once you have these numbers, you will simply add those numbers with the corresponding rows. How you can get the row number as well? So let's decode this. If you are given A1, what will the value of row plus column? So the value of column will be, nothing but, if we say that this is, let's suppose, string S, so it will be S of 0, which is character A. From this, we will subtract character A and add 1. So this will turn out to be 1. Similarly, the value of row will be S of 1. S of 1. Now, this is a character. To get row number, to get the actual number from it, you have to subtract character 0 from it. So you will get 1 again. And why this is working? Why this is actually working? This is because S of 1 is nothing but character 1. What is the ASCII value of character 1? If you observe, the ASCII value of character 1 is nothing but ASCII value of 0 plus 1. So when you subtract character 0 from it, what is the result? You will get 1, right? This is how you are obtaining column and row. And once you have column and row, now you can simply add them up. If the result is even, this means that the color is black. And if the result is odd, this means that the color is white. That's the simple thing. So let's jump on to the code. The code is this. So first of all, for the first coordinate, we will figure out what is the value of row and column. And then for the second coordinate, we will figure out what is the value of row and column. So for the first coordinate, the value of row is nothing but coordinate of 0 minus A plus 1. Okay. So you can say this as column as well. You can say that this is column 1. This is row 1. This is column 2. And this is row 2. Okay. So what is the value of column 1? Column 1 is nothing but coordinate of 0 minus character 8 plus 1. Similarly, what is the value of row 1? Row 1 is nothing but coordinate of 1 minus character 0. Similarly, what is the column 2? Column 2 is nothing but coordinate 2 of 0 minus character 8 plus 1. And row 2 is nothing but coordinate 2 of 1, that is character 3 minus character 0. Now, when will they have same color? They will have same color either when R1 plus C1 is odd as well as R2 plus C2 is odd, or when R1 plus C1 is even and R2 plus C2 is even as well. So what you need to return? You need to return R1 plus C1 modulo 2 is equal to R2 plus C2 modulo 2. That is, when their sum is divided by 2, they will yield the same result. Either both will give as 1 or both will give as 0. If this is true, then we will return true, like either both of them have white color or both of them have black color. Else, if this is not happening, we will return false. So this is like, this is the way how you can write this. You are returning this. So if this and this are equal, it will return true. Otherwise, this will return false. So this was the simple code for this problem. So let's jump on to the second problem. So the name of the question is kth nearest obstacle queries. So let's go through the problem statement. There is an infinite 2D plane. You are given a positive integer k. You are also given a 2D array queries which contains the following queries. So queries of I is x comma y. So you build an obstacle at coordinate x comma y in the plane. It is guaranteed that there is no obstacle at this coordinate when this query is made. So you are given that, okay, all coordinates are unique. So after each query, you need to find the distance of the kth nearest obstacle from the origin. So you need to return an integer array result, where result of I denote the kth nearest obstacle after query I, or result of I is -1 if there are less than k obstacles. Note that initially there are no obstacles anywhere, and the distance of an obstacle at coordinate x comma y is given to you from the origin. It is nothing but modulo x plus modulo y. So let's understand the question via this example. Okay. So see, you are given this. So the coordinates given to you, or the queries that are given to you, are 1, 2, 3, 4, 2, 3, and -3, 0. So the first coordinate is 1, 2. So you plot 1, 2. What is the distance of 1, 2 from origin? Now it's given to you that distance for any coordinate x, y from the origin is modulo x plus modulo y. So can I say that distance of 1, 2 is nothing but 1 plus 2, which is equals to 3. So now you have one coordinate 3, and you are told that what is the coordinate that is at the second most distance from the origin. So are there k coordinates? Are there k coordinates present? No, you have only one coordinate. You don't have two coordinates. So the answer for this particular query will be -1. Because to tell that what is the coordinate value or what is the distance value that is at the kth largest distance from the origin, you at least need to have those coordinates, right? You at least need to have k number of coordinates, but you don't have k number of coordinates. So the answer to this particular query will be -1. Now you add 3, 4. Now you have one more coordinate 3, 4. What is the distance of this coordinate from the origin? It is 3 plus 4, which is equals to 7. So now you have k coordinates. So can you tell me that which coordinate is at the kth distance from the origin? So the first coordinate is 3, the second one is 7. So 7 is the second maximum value in this second minimum value, I would say, in this coordinate plane, isn't it? In this distance plane. If you simply short this 3 and 7, 7 will come at the second position. So the answer to this particular query will be 7. Okay. Let's move on to the third coordinate. So the third coordinate is 2, 3. What is its distance from the origin? Its distance from the origin is 2 plus 3, which is 5. So now if you simply short these distances, you have 3, 5, 7. So again, the kth largest, kth minimum distance will be 5, isn't it? So the answer to this query will be 5. And you have one more coordinate, -3, 0. What will be its distance from the origin? You know that the distance is modulo x plus modulo y. So it will be basically mod of -3, which is 3, plus 0, which is equals to 3. Now again, if you short this, you will get 3, 3, 5, 7. 3, 3, 5, 7. And the second minimum distance is 3. So the answer will be 3. So this will be the answer to the test case given. -1, 7, 5, and 3. Okay. I hope the question is clear. So how we can do this? How we can do this? One approach that comes to our mind, the one approach that by looking to this question comes to our mind is that, okay, what we need to do every time we get a distance, if we simply push this distance in our vector, we are pushing this distance, then we short this vector and just return the kth index value if it exists, then that will be our answer. Like you have 3, push 3 in the vector, okay, push 3 in this vector, short this vector. The shorted vector is 3. You want a kth index value. That is, if the value of k is 2, you want to return the second value in this vector, or basically the value present at the first index, isn't it? Because we consider zero-based indexing in vector, so we need to return the value present at the first index. But do we have any value in this first index? No, because the size of the vector is 1. So we say that, okay, answer is -1. Then at second, we get a distance of 7. Push that in the vector and short the vector. So you get this as your vector. Now if you return the value present at the first index, it will work. So you will get 7. Okay. Now you have a distance of 5. Again, push this in the vector. You will get and short the vector. So the vector will be this 3, 5, 7. 3, 5, 7. And you will return the value present at the first index, which is 5. So you will get your answer. Then you get a distance of 3. Push in the vector and short the vector. You will get the vector as 3, 3, 5, 7. Return the value present at the first index, that is 3. And you will get your answer. But if you do this, you will get TL, right? Because at every point of time, you are shorting the vector. So that would produce a TLE. Because looking at the constants, if you look up to the constants, and the number of queries is of the order of 2 into 10 power 5. So it will produce TL. How you can solve this? How you can do this? So the one approach is clear that, okay, every time I am concerned only of first k values. Do you agree? Do you agree? How I can say that? See, when I had this vector with me, 3, 5, 7. When I had this vector with me, 3, 5, 7, after the end of the third query, I have this. Now just tell me, is this 7 is of any use to us? Do we ever need 7? Because whatever distance we push in now, that distance can either be greater than 5 or lesser than 5. If it is lesser than 5, so that will be the answer. If it is greater than 5, then 5 will be the answer. But this 7 can never be the answer now. this 7 can never be the answer now if the value of k is 2. So do we actually need this 7? The answer is no. So we will use this logic to solve our question. What is the logic? The logic is that the first distance was 3. Okay. So what you do, you maintain a multiset. You maintain a multiset. What does this multiset does? This multiset stores element in, like, if I in ascending or descending order, that is in ordered value, and duplicate elements are allowed. That is, if you, let's suppose, give this multiset value 1, 5, 7, 1. So the order in which the elements will be stored in this multiset will be 1, 1, 5, and 7. Okay. So what you do, you get a value 3. You push this in your multiset. So your multiset contains 3. Okay. And what you know, that the size of this multiset is lesser than k. So this can't be our answer. So the answer for this query will be -1. Then you get a distance of 7. Push this value into your multiset, 3 and 7. Now, again, the value of k is, the size of multiset is 2 only. So, okay, we need both these values. So the answer will be 7. That is the last element of this multiset. Okay. Let me repeat. The answer is the last element of multiset. Now you will see the beauty when you get the value 5. Once you get the value 5 and you know that your multiset already contains k elements, your multiset already contains k elements. So if I am telling that, okay, this 5 is useful for me, so there is at least one element in this which is not useful for me. And can you guess that which element is not useful for me? If I have the value 5, then which element is of no use to us? Yeah, you guessed it right. The element that is of no use to us is this 7. This 7 is of no use to us. So what we will do? We will remove this 7 and add 5. So our multiset will now be 3 and 5. And the value that is present at the last of this multiset is 5. So 5 will be our answer. And you can understand that why we are returning the value that is present at the last of the multiset. Because our multiset contains k elements. Our multiset contains k elements, and we know that the last element will be our answer because last element is the biggest of all those k elements. Now you get 3. Now you get distance as 3. So again, since 5 is greater than 3, so I know this 5 is of no use to us. We will delete this 5 and insert 3 in our multiset. So now our multiset will contain this, and the last value of multiset is 3. So the answer to our query will be 3. So this is actually the approach to our question, that we are removing the element that is of no use to us and inserting the element. Now you can understand that if our multiset contains k values, if our multiset, let's suppose the value of k was 3, multiset contains k values, let's suppose this value is 4, and you get a value 5. Will you insert this 5 in this multiset? No, right? Because this 5 is of no use to us if we have the last element that is the biggest element of these k elements as 4. So this 5 is of no use to us. But if we, let's suppose, have 6 over there. If we have 6 over there, so we know that this 5 is of use to us. So we will delete this 6 and insert 5 instead. Okay. So this is actually what the logic to this question is. So let's understand via the code. So first of all, constructed a vector in the answer that we are going to return. Okay. Then constructed a multiset, and then we are going to each and every queries one by one. So what is the distance from the origin for that particular query? It is nothing but the absolute value of the x coordinate plus the absolute value of y coordinate. So we stored this in the variable temp, which is nothing but absolute value of it of 0 plus absolute value of it of 1. Now, if the size of the multiset is lesser than k minus 1, so can we say that even if we push this element inside our multiset, we will not get the value of size k? That is, if let's suppose the value of k is 3 and your multiset contains only one element. Your multiset contains only one element. Now, even if you push one more element to this multiset, the size will not become k. So till now, the answer of the query will remain as -1. So what we did is, if size of the multiset is lesser than k minus 1, to our multiset we inserted the value temp. To our answer we pushed back -1 because we have not completed case coordinates till now, and we continue. Else, if the size of the multiset is equal to k minus 1, what does this mean? This means that if we insert this new distance now, the size of the multiset will become exact k. So what we did, we inserted this to our multiset, pushed back the last value of this multiset. Now this is how you can get the last value of this multiset, by using r begin. So star st.r begin, you can get this last value and you simply continue. Okay. Now, if the size of the multiset is not equals to k minus 1, so it is, we know that since our multiset contains a maximum of k elements, this means that the size of the multiset is now k, and we have a new distance temp with us. So we have to remove one element from the multiset if we want to insert this temp. Now we will check that whether we actually want to insert this temp in this multiset or not. How we can check that? If the last value of the multiset is greater than what actually we got our temp as, so we know that, okay, now we have to erase this last value and insert temp. So this is how you can erase the last value from the multiset. So st.erase, st.find star st.r begin. Okay. So this is how you can erase the last value from the multiset and inserted the value that is the new distance temp to this multiset. Once you have done this, so you know now your multiset contains the first k elements, and the largest of those k elements is present as the last value of the multiset. So in your answer, you simply push back star st.r begin. That is basically the value of the last value of the multiset. Once you have done this for every query, so you simply return your answer. So this is actually the code to this question. Now the alternate approach to this would be that instead of using multiset, you can even use priority queue as well. So yeah, priority queue can also be used. And if anyone is not comfortable with this multiset, I would recommend that you can learn how the syntax of multiset, because it is super important. You can use multisets in many of the questions. But for now, if you don't know multiset, you can even implement the same thing via priority queue as well. Okay. So I hope we are done for this question. So let's jump on to the third question. Okay. So the name of the question is select cells in grid with maximum score. So let's go through the problem statement. You are given a 2D matrix grid consisting of positive integers. You have to select one or more cells from the matrix such that the following conditions are satisfied. That no two selected cells are in the same row of the matrix, and the values in the set of selected cells are unique. So your score will be sum of the values of the selected cells to return the maximum score you can achieve. Like for example, if I take this particular grid as example, if I take this as my example, so just observe what are the conditions I want. Let's write down those conditions. The conditions I want are maximize sum. This is one condition. The constraint is that from every row, at most one element can be picked. Okay. And the third constant is that all the picked values should be unique. All the picked values should be unique. So let's see whether these selections satisfy all these conditions or not. So first of all, you can observe that from every row, we have selected only one value. This pink cells represent the values selected. So from every row, there is only one value selected. And all the selected values are unique. What are the selected values? 4, 1, and 3. So all these selected values are unique. And you can observe that you will not get any other combination that will maximize the sum. So the answer to this query will be 4. Answer to this particular grid will be 4 plus 1 plus 3. That is 8. Let us look up to some other grid as well. Let us take this example as well. So we have this example. So what is our aim? Our aim is to maximize the sum, right? So what we will try? We will try to take one of the 8s. Just remember, our aim is to maximize the sum. And while maximizing the sum, we would have taken 2 8s as well. But we are told that all the picked values should be unique. So we can't pick 2 8s. So what we do? We pick this particular 8 and this 7, and the maximum value obtained is 50. Now the observation is that if you pick this particular 8, and not this particular 8, in that case, you have to pick a value. You are not allowed to pick this 7 because from every row you can pick at most one element. So you are not allowed to pick this 7. So you have to pick a value from this particular row, and the maximum value from this particular row is 3. That is not picked. Yeah, I know 8 is the maximum value, but that is already picked, right? So 3 is the maximum value that is not picked. So the answer would be 8 plus 3, that is 11. So even if both of these two rows contain 8, it is important that from which particular row we are taking this 8. Okay. So this is actually the question, is that you want to maximize the sum so that you don't pick any more than one values from any row, and all the picked values should be. I hope the question is clear to everyone. If it is not clear till now, just give a pause and try to understand what actually the question is. Now, once you understand the question, how we can solve this? How we can actually attempt to solve this question? So one observation is that what is our final aim? What is our final aim? Final aim is to maximize the sum. Agree? Now, while maximizing the sum, what will be our aim? That okay, if we observe one thing, that the values of this grid of I of j is in the range of 1 to 100. Okay. So our aim will be that if we have 100 somewhere, so we should pick this 100. Anyhow, we should pick this 100. We should try to pick this 100. We should try this. Okay. If we, let's suppose, have 99 somewhere, we should try to pick this 99. Like for example, if you had these values 876 and 832, when you had these values, what was your aim? Said, okay, you want to maximize the sum. You want to maximize the sum, and the maximum value present over here is 8. Sure, I should pick some 8. I should take some 8. This should be our aim, that I should pick some 8. But the dilemma was that 8 is contained in this row also. 8 is contained in this row also. Then which 8 to pick? Which 8 to pick? We should pick 8 in this particular row, or we should pick 8 in this particular row. Now we are confused, right? So to solve this dilemma, what we do is we do a recursion. What we do? We say that, okay, at the first case, we had two rows that were containing 8. Let's say this is row 1 and this is row 2. So let's pick the 8 that was present in row 1. So you pick the 8 that is present in row 1. So can I say that you can't pick any values now that is present in row 1? Can I say this? Yeah. Okay. What is the second value after 8? The value is 7. The second value, the largest value lesser than 8 is 7. Now you will try to pick 7. Is 7 present in the grid? Yes, it is present. In which row it is present? It is present in row 1. But you already picked one value from row 1, so you know that you can't pick 7. Okay. So let's move on to 6. Is 6 present? Yes, present. In which row it is present? It is present in row 1, which is from which the value is already picked. So you can't take 6 as well. Then you go to 5. Is 5 present? No. Okay, let's move on. 4 present? No. 3 present? Yes. In which row it is present? Row 2. And have we picked any value from row 2 yet? No. So what we will do, we will pick this 3, add this to our answer, and our answer will be 11. Now just move on to the second case, when you were picking 8 from this particular row. That is, you picked row 8 from row 2. So you picked 8. Now you move on to 7. Is 7 present in this grid? Yes. In which row it is present? It is present in row 1 only. So, and you have not picked any value from row 1 yet. So what you will do, you will pick up this 7 and your answer will become 50. Now, if you observe one thing. When we picked 8 from row 2 and went to 7, and we know that 7 is present in this row 1, we wanted to check that whether have we picked up any values from row 1 yet. Now, how to keep track of that? So for this, we are going to use bit masking. Because we know that the maximum number of rows that we can have is 10 only. So we will maintain 10 bits, number containing 10 bits. So if let's suppose the maximum number of rows that you have is n, so you will simply maintain the number containing n bits. And every bit will signify that whether we have taken that row or not. So the 0th bit will signify that have we taken 0th row. First bit will signify have we taken first row. Second bit will signify have we taken second row. Third bit will signify have we taken third row. So if we know this, that have we taken a particular row or not, we can easily reach to our answer, isn't it? So this is nothing but a question of DP with bit masking. Because if you start with the maximum value, so the maximum value can be 100, right? So you are decrementing all these values one by one. So every value, so how many maximum values you are traversing? 100 values, right? And what is the mask that you need to maintain? You need to maintain a mask of 2 power n, right? So to check that which row you have picked or not. So the time complexity will become 100 multiplied by 2 power n. This will be the total number of states. And for the transition, for DP transition, can I say that for every number, I am checking that which all rows contain that number. For every number, I am checking which all rows contain that number. So if we have some vector such that for every number I store that, okay, which all numbers are containing this, which all rows are containing this number. If I have this, so what is the maximum size of this vector for a particular number? For a particular number 10, just tell me what are the maximum number of rows that can contain this number. The maximum number of rows that can contain this number is n. So the time of transition will become n. So the time complexity will become 100 multiplied by 2 power n multiplied by n. So you can easily solve it via a DP. So let me summarize the approach. The approach is that we first of all find out what is the maximum number in the grid. Then we are keep on going to each and every maximum number. Like let's suppose the maximum number is 99. So first of all, we went to 99. Then we keep on decrementing this maximum number. Then we went to 98. Then we went to 97. Then we went to 96, something like this. For every number, we are checking that what all rows are contained, what all rows contains this number. And then we are checking that, okay, if let's suppose 99 is contained in row 2, row 3, and row 4, and 98 is contained in row 3 and row 5. Okay. So let's suppose this number 99 we took from row 3. So our mask will tell us the third bit of our mask will be set. Third bit will be set. So when we go to 98 and when we try to take this particular row, our mask will tell me, no, don't take this particular row since it is already taken. So we will move on to the next row that contains this number 98. And if let's suppose what if this was not there? You have only 3. So you will not take this number 98 and you will move on to the next number. So the basic intuition of this problem was that every time when we try, first of all, we will try to take the maximum numbers. The second intuition was that whenever you try to take a number, you know that which all rows contain that number, that can be easily found. But how to decide that whether we can take that number from that particular row or not? Because it may be that we have taken some other numbers from that particular row and we are allowed to take only one number from a row. So to keep track that from which all rows we have took a number, we are maintaining our mask that is of size n, where if a bit is set, this means that from this particular row we have taken the number already, and if a bit is unset, so this means that from this particular row we have not taken the number yet. So this is actually the approach to this question. So let's jump on to the code. So first of all, in our variable n, we are storing the size of the grid, and in the variable m, storing the size of the number of columns. Okay. And we are resizing our DP to 101 and one left shift n minus 1. What does this mean? We have maintained one vector A and vector DP. Let me tell you what they are doing. So DP is a normal, as the name suggests, DP, we are doing it for memorization step. So what will be the value of the first state? The maximum number that can be present in the grid is 100, right? So maximum, the size of this will be the first state, the first element will be 101. And the size of the second, the number of columns is basically the mask, that is one left shift n. Because if you have n rows, so the maximum number that we can obtain is when we have taken numbers from all the rows. This means that all the n bits are set. And when all the n bits are set, what is this value? This value is 1 left shift n minus 1, right? So you want numbers from 0 to 1 left shift n minus 1. So what is the size? The size becomes 1 left shift n, isn't it? So we maintain 1 left shift n and initialized our dp with minus 1. Then in our A, what is this vector A doing? This vector is actually storing that for a particular number, what all rows contain this number. Okay. So the maximum number is 100. So we made this of size 101 and this is empty. Initialized our maxi to 0. This maxi variable will store the maximum value in the grid. From all the rows, combining all the rows, what is the maximum value? Okay. So now we are traversing over all the cells of the grid one by one. So this is for the rows and this is for the columns. In our A of grid of I of j, we are pushing back I. That if the value, we know that the value of grid, the value of this particular cell is nothing but grid of I of j. So for this particular value is contained in row I, right? This particular value is contained in row I. And for every value, we are storing that what all rows contain that value. So we did simply this, that A of grid of I of j dot pushback I. And we updated our maxi variable with the max of maxi comma grid of I of j, because at the end, this maxi variable will be storing the maximum value in the grid. Okay. So once this is clear, we are calculating our answer. The name of the function is cal. We have made one function which is calculating if the maximum value in the array is maxi, and we have taken 0 rows till now. If we have not taken any rows till now, what will be the value of mask? The value of mask will be 0, right? If we have n rows, so we have not taken any row till now. So all the bits are unset. So what is this value? This value is 0, right? So we have started with the mask value of 0. Let's see what we can do. So we are currently at number n and we have a mask. If we have reached number n as 0, can we return 0? Can we return 0 once we reach the value of n as 0? Yes, because we know that the minimum element present in the grid is 1. So once we reach our n as 0, so we are not going to take any more number. So we are not going to generate any more sum. So we are returning 0. Else, if dp of n of mask is not equals to minus 1, this is a simple memoization step. So we are returning dp of n of mask. Now, let's see how we are calculating the answer, how we are actually calculating the answer. So one of the step is that we don't take this number n. That okay, there is a number n and we don't take this number n. So we, in our answer, first of all, we are calculating with the number n minus 1 and the mask will remain the same. Now, if we have the desire to take the number, so what we do, we go to each and every number, each and every row that contain this number. Now, how we can go to each and every row that contain this number? So if you remember, for in our vector A, for every number, we contain the row that contain that number, right? So we went to each and every row that contains that number. And if in our mask, that particular row is set, this means, what does this mean? This means that this particular row is already taken. We can't take this row. In that case, we continue. But if this particular row, if this particular bit was unset, this means that this particular row is not taken till now. So we updated our answer with max of answer comma this number n, because we are taking this number n plus the result of n minus 1 comma mask or 1 left shift x. So since we have taken this xth row, so we have to set that particular row in our mask. So what we did, max of answer equals to max of answer comma this number taken n plus calculation of n minus 1 mask or 1 left shift x. This is how you set the xth bit in the mask. Okay. Once you're done with this, so you know your answer contains the maximum answer once you reach this particular state with value n and mask. So you are returning dp of n of mask as answer. So this is how you can solve this question. If I just try to tell you the time complexity of this code, so what it will be? So it will be like the maximum number of this dp, the number of states of this dp is n multiplied by 2 power n. And for transition, the maximum transition time will be 10, because the maximum number of rows where this particular number can come is 10. So you can say that the total time complexity is n multiplied by 2 power n multiplied by n. So it is basically n square multiplied by big O of n square multiplied by 2 power n. And looking at the constant, the value of n is maximum given to you as 10. So you can say that your answer will be, oh, sorry, this is not n, this is actually 100. The maximum value of this is 100, that is maximum. So you can say that time complexity is big O of 100 multiplied by 2 power n multiplied by n. Because in transition, the maximum number of rows that can contain a number is n. So yeah, this is the time complexity. So if you look up, so the maximum time complexity will be 2 power 10 multiplied by 10, which will definitely work. 1024 multiplied by 1000 works, isn't it? So this is how you can solve this question. The main part in this question was that you wanted to keep track of what all rows you took. Rows 10. So to keep track of this, here was the intuition that led you to jump to bit mask. Okay, fine. So let's jump on to the fourth question. So the name of the question is maximum XOR score subarray queries. Let's go through the problem statement. You are given an array nums of n integers and a 2D integer array queries of size q, where queries of I is li to ri. So for each query, you must find the maximum XOR score of any subarray of nums li to ri. So now you are given an array nums of n integers. You are given queries, q queries. Queries is of the form li ri. And for every query, you need to print that what is the maximum XOR score of the subarray of nums from li to ri. Now, how you are calculating this XOR score? So XOR score of an array A is found by repeatedly applying the following operations on A so that only one element remains, that is the score. So what you're doing, you're simultaneously replacing AI with AI XOR AI plus 1 for all indices I except the last one, and you are removing the last element of A. So you need to return array answer of size q, where answer of I is the answer to the query I. So let's understand first of all what the question is. Okay. So So this is the array. So first of all, let's understand what actually we mean by XOR score. How actually we are calculating XOR score. What actually this is. So let's suppose I give you that my array is 8, 4, and 32. So the XOR score for this array would be 8 XOR 4. So the first element gets replaced by AI is getting replaced by AI XOR AI plus 1. So first element gets replaced by 8 XOR 4. The second element gets replaced by 4 XOR 32. Once you do this, you remove the last element. So this element is removed. Now you have these two elements. You have to repeatedly perform the same operation until there is only one element remaining. So you have two elements remaining till now. So again, you will perform the same operation. The first element will get replaced by 8 XOR 4 XOR 4 XOR 32. And the last element will get removed. So once you do this, what is the answer? The answer for this is 8 XOR 32. So the answer to the query. So what is 8 XOR 32? 8 XOR 32 is 40, isn't it? So the answer for this array, the XOR score for this subarray would be 40. This is how you are calculating the XOR. Once you understand how you are calculating the XOR score, so let's understand what actually we are doing in query. How actually we are finding the query. So let's suppose you are given a query 0 to 2. So you are given the array nums, which is 2, 8, 4, 32. Two, 8, 4, 32, 16, 1. And you are given a query 0 to 2. That is the value of L is 0 and the R is 2. You have to compute the answer 0 to 2. So the answer to this will be from 0 till 2. What all subarrays are present? First of all, figure out what all subarrays are present. So from 0 to 2, the subarrays present are this 2, then this 8, then this 4, then this 2, 8, then this 8, 4, and then this 2, 8, 4. Do you agree? These all are the subarrays present from index 0 to index 2. These all are the subarrays. Now, according to the question, for this particular query, you calculate XOR score of all these subarrays. What is the XOR score of this? It is 2. Only one element is remaining. What is the XOR score for this? It is 8. For this, it is 4. What is the XOR score for 2 and 8? 2, 8. So the first element gets replaced by 2 XOR 8 and the 8 gets removed. So this value is nothing but 10. XOR score for this similarly will be 12 and XOR score for this similarly will be, if you compute, the first element is 2 XOR 8, the second element is 8 XOR 4 and the third element is 4, that gets removed. Then the first element becomes 2 XOR 8, XOR 8, XOR 4 and the second element gets removed. So the value for this is 6. The XOR value for this is 6. So out of all these XOR scores of all possible subarrays from 0 to 2, you need to return the maximum XOR score, that is 12. So if you see, the answer for the first query in this particular question is 12. This is how actually you are computing the answer for the query. So I hope the question is clear to everyone what actually we want to do. Now, how we can do this? How we can do this? So looking up to the constraints, we looked at, okay, the value of n, that is the number of elements in the array, is of the order of 2000. Okay. Number of queries that we have is 10 power 5. So if we are given that you have to answer query from L to R, and if you go on to this L to R, for every subarray you compute that XOR value, and you return the maximum XOR value, that will definitely produce a TL, right? That will definitely produce a TL. So how you can actually solve it? Okay. So if I tell you that you know the answer for this L to R from before, if you know the answer from L to R from before, so for every query, you can answer this in big of one time, right? You can answer this in big of one time, right? Nice. So how to actually pre-compute the values from L to R? So this was one of the intuition that came to my mind, that, okay, how to compute the values from L to R? So what I did was, I assumed that, okay, let's observe how actually these XOR values are getting computed. So if let's suppose my array is A2, A3, A1, A2, A3, how actually this XOR value gets computed? It is like A1, XOR A2, then A2 XOR A3, and this A3 gets deleted. And then this value becomes A1 XOR A2, XOR A2, XOR A2, XOR A3. That is XOR of these two values. And the last value gets removed. Okay. So when we had the value A1, A2, A3, we had this our answer. That is from starting from A1, when we were taking elements till A3, this was the answer we got. Okay. So starting at index 1 and having length as 3, this is our answer. Agree? Now, just do one thing. Start at index 1 again, but just increase your length to 4. Just increase your length to 4. Let's compute what we can get. We are computing the XOR value. Okay, XOR sum value, what actually was given. So the first value gets replaced by A1 XOR A2. Second value gets replaced by A2 XOR A3. Third value gets replaced by A3 XOR A4, and the last value gets deleted. Fine. Now again, do the same thing until we get one numbers. Okay. So the first value gets replaced by A1 XOR A2 XOR A2 XOR A3, isn't it? And the second value gets replaced by A2 XOR A3 XOR A3 XOR A4, and the last value gets deleted, isn't it? Let's write the last one. Last value is A1 XOR A2 XOR A2 XOR A3 XOR A2 XOR A3 XOR A3 XOR A4. We got this our answer, and this is a beautiful. Let me explain you why. Let's suppose we started at A1. And took subarrays till length equals to 3. That is, we had the numbers A1, A2, A3, A4. We started at A1 and took the subarrays from 3. So what was the result we got? The result we got was A1 XOR A2, XOR A2, XOR A3, isn't it? Now, start at A2 now and take the same length, 3. Start at A2 and take the same length, 3. So what XOR value you will get? A2 XOR A3 XOR A3 XOR A4. Agree? Now, starting at A1 and taking length as 4, can I say that the result was this only? Just observe. Can I say that the result was this only? Isn't it? So can I say that for any index I, if let's suppose I am computing this XOR value for any index I am calculating what is the XOR value if the length is 1, if the length is 2, if the length is 3, if the length is 4, if the length is 5, I am computing these XOR values. Okay. So can I say that the XOR value for this index I with a particular length will be nothing but the XOR value of this index I with length as len minus 1 XOR value of the very next index with length as len minus 1. Can I say this? Can I say this? Just observe, I did the same thing. Starting at index 1, I wanted to compute the XOR value till I am taking the length as 4. So it was nothing but starting at 1, taking length as 3, and starting at 2, that is the very next index to 1, and taking length as 3. Once you get this thing clear, so what comes to your mind? That for any index I, to compute the answer for length, we have to know for index I and I plus 1, I have to know what is the value for length minus 1. So what I did was, I went in the order of length, that int len equals to 1, len lesser than equals to n, len plus plus. I went in the order of len, and then I went in the order of the possible starting values. So possible starting values are 0, I lesser than n, I plus plus. So now if I am writing dp, I am writing this XOR value of I of len. I already know what is the value of XOR value of I of len minus 1. I already know this because for the earlier length, I have already calculated this. So I already know this. Plus XOR value of I plus 1 of len minus 1. And this is also already known because for every index, I already have the values computed till len minus 1 if I am at a present length. So once you understand this, so compute this XOR value. Okay. Now how this is helping to us? What we have calculated, effectively what we have calculated for every index, we have XOR values. Actually, not the XOR value, that is what we needed to calculate the XOR score. For every index, we have the XOR score for subarrays, starting at that particular index. We have this, right? That okay, if we are starting at this index, so if the subarray length is 1, then what is the answer? If the subarray length is 2, what is the answer? If the subarray length is 3, what is the answer? If the subarray length is 4, what is the answer? For every index, we have pre-computed it. Once we have that, now my aim is that if I give you a subarray starting from L to R, if I give you this subarray, you should be able to tell me the value for this query. If the query is L to R, you should be able to tell me the value of this query. Now, can someone say me what will be the value of this query? Can I say that the value of this query will be nothing but all subarrays starting at L? Like let me take some example. The value of L is, let's suppose, 0 and the value of R is 2. So you have 3 numbers. Can I say the value of this query will be nothing but all these, the maximum of XOR score of all these subarrays? What all subarrays? Subarrays starting at this index and ending till this particular index. That is, starting at this index, what all subarrays we have? A1, comma A2, and A1, comma A2, comma A3. Then starting at A2, what we have? A2, A2, comma A3. And then starting at this subarray, what we have this A3. So for this particular query, L equals to 0, R equals to 2, can I say that my answer will be nothing but maximum of all these scores? Can I say this? My answer will be nothing but maximum of all these scores. So what I will do is, I will construct TP such that for every index I and length len, I get that what is the maximum possible answer. So like what, where we will get the answer for this particular query? For this particular query, our answer will be stored at for every subarray starting at where the minimum starting point is 0. And what is the length? The length is 3, right? R minus L plus 1. The length is 3. So dp of 0 of 3 should contain the maximum of all these source code values. How we can do that? Can I say that dp of I of len will be nothing but what are the possible thing? The possible thing is that we don't include this element in our array, in our score XOR score value. If we don't include this particular element, so whatever answer we got till this particular index for the value len minus 1 in our dp, that is one possible answer. So can I say dp of I of len is nothing but max of dp of I plus 1 of len minus 1, comma. Now, if we are taking this value, so there are two options. The two options are either we consider the entire array or we don't consider the entire array. If we are not considering the entire array, so for that, do we have the answer already in dp of I of len minus 1? Because till len minus 1, what is the maximum score that is already stored, isn't it? So we already have answer in that. So, comma, dp of I of len minus 1, comma. If we are considering this entire array, so what, from where we will get the XOR score of this thing? In our XOR score that is already computed. So XOR score of I of len. If we take maximum of all these three values, we will have our dp of I of len constructed. And once we have this, once we have the query L and R, our answer will be nothing but dp of L of R minus L plus 1. That is dp of L and len. This will be our answer. So let me repeat how we actually calculated this TP. What we did, we want that if the value of our starting point is I, and if we are considering till len, if our starting point is, let's suppose A1, and we are allowed to consider numbers or the subarrays till A4. So I will store this value in dp of 1 of 4, that is the length is 4. And what all subarrays I have? The subarrays I have is A1, A1, A2, A1, A2, A3, A1, A2, A3, A4, then A2, A2, A3, A2, A3, A4, then we have A3, A3, A4, and we have A4. We have all these subarrays. We want to take the maximum from them, isn't it? So to compute this, what we told is that, okay, let's suppose we are not including this particular ith element. If we are not doing that, we are not considering the starting element. So can I say the answer will be dp of I plus 1 of len? That, okay, if we are starting at index I plus 1, and if we have the value of len minus 1, then what is the answer? If we have that, then we can say that, okay, that is one possible answer. Because if you are considering this subarray, just think, if you are considering this subarray, what will be the answer for this query? If L is 1 and R is 4, what will be the answer for this query? One possibility, you don't consider this element. If you don't do that, this becomes your array now. So the answer for this is already stored in dp of I plus 1 of len minus 1, isn't it? This is already stored. So this is one possibility. The other possibility that you consider this element. If you are considering this element, now again, there are two possibilities. Either you take this entire array or you don't take this entire array. If you don't take this entire array, so the maximum number of elements that you will take is 3, that is len minus 1. And you already have the answer computed for len minus 1. So one possibility is dp of I of len minus 1. Other possibility is that if you are considering this entire array, that is, you are taking the XOR code from all these from L to R. So the value of the XOR code of this is already stored in your XOR code pre-computed vector. So XOR score of I and len. So this XOR score I to len already stored this value. So you will take this value. So if you simply take maximum of this, this, and this, you will get your answer. So this was actually the logic for this question. So let me go through the code. Once you understand the logic, the implementation completely depends on you. This is one of the possible implementations. So first of all, in our n, we have the size of this nums. And then we computed one XOR values vector, which is of size n cross n. So which is of size n cross n plus 1 cross n plus 1. And this will store that for every index I, if we are considering the subarray of length 1, 2, 3, 4, 5 up till n, length n, because length n is the maximum possible length we can consider, then what is the XOR score we are obtaining? So we are going in the order of length first and then the index. This is clear because why we are doing this? First of all, in the order of len and then index, because for computing this I of len, we require answer till len minus 1, isn't it? That's the reason we are doing that. Okay. So if the value of length is 1, can I say if the value of length is 1, that is my array contains only a single element. So this will only be the XOR score. We will not do any operation in that. So if the value of len is 1, the XOR value of I, that is starting at index I, considering length 1, is nums of I only. Else, if the value of I plus len is greater than n, what does this mean? This means that you are at a current index I, and when you add this length value, it becomes greater than n. That is, you can't take, starting at index I, you can't take length subarray. Like if let's suppose you have A1, A2, A3, this is the element. And if let's suppose your I is 1, that is you are starting at the second element. And the value of your length is 3. Value of your length is 3. So can you take 3 elements starting at this index? The maximum number of length, the maximum value of length that you can have is 2, right? You can't take 3 elements starting at this particular index. So in that case, the value of I plus len will exceed the value of n. If this is the case, you know that, okay, you don't have anything. So what I did is, for that, in XOR values of I of len, simply a value 0 is assigned. If this is not the case, so as already discussed, XOR value of I to len, that is starting at index I and considering length of len, the answer is nothing but XOR value of I till len minus 1, XOR value of I plus 1 to len minus 1. This is something that we already discussed. Once you have this XOR values computed, now you will construct a DP of size n plus 1 to n plus 1, where DP of I of j will be, DP of I of j will tell me that starting at index I and having maximum length as j, what is the answer? Okay. That is, if you are at L and the last subarray index that you can take is R, then you will get its answer from DP of L of R minus L plus 1. That is starting at L and considering the maximum length of this, what is the answer? So you are going again in the order of length and then in the basis of index. If the length is 1, so you know that DP of I of len will become XOR value of I of len. If this is not the case, so what will be DP of I of len? It will be nothing but maximum of whatever is the value of DP of I plus 1 of len minus 1. That is, if you are not considering the first element. So whatever is the value for this, you have that computed in your DP already. So maximum of DP of I plus 1 len minus 1, comma, DP of I of len minus 1. That is, you are not considering the entire subarray, you are only considering the subarray till length minus 1. So DP of I of len minus 1, comma, if you are considering the entire subarray. So there is only one possible subarray, right? That is the entire subarray from L to R. So for that, the value is contained in XOR values of I of len. So what you did, you went to XOR values of I of len and took max of that as well. So now your DP of I of len will contain the required answer. Once you have that, construct the vector range result, go to each and every query. The value of L is Q of 0, the value of R is Q of 1. What is the value of length? The value of length is R minus L plus 1. So in your result, you simply push back DP of L of length and return this result. Once you have this, so you will get your desired result. So yeah, the main thing in this question was figuring out this thing, that XOR values of I of len is equal to XOR values of I of len minus 1, XOR of XOR values of I plus 1 len minus 1. Once you have this thing computed, so computing now, then once you have this thing figured out, so figuring out this step, that is the DP step, that is starting at index I and considering the maximum length as len, was easy. Okay. Once you do this, so for your query, you can answer everything in big of one time. For every query, you can answer the result in big of one time. So this was actually the logic behind this question. So I hope all of you got it. Thank you.